Well, this presentation is about the expansion of the product rule. And as we have already known, the product rule of f times g is the derivative of f times g plus the derivative of g times f. And here comes the question is that when we have three functions multiplying together, how do we take the derivative of it? Well, remember, if we use properly the product rule we have already had properly, then we can easily get the derivative of these, well, seems complicated function. Well, let's take a look. Well, the derivative of f times g times h is, well, we use another way to write it, which is f times g times h. Well, in this case, we take the f and g here as the first function over here, and we take h as the second function over here. And we take the derivative as we have done before. We take the derivative of f times g times h plus the derivative of h times f times g. Well, this part is exactly what we have talked about, so it is equal to df dx times g plus dg dx times f with a bracket and times h, and write the rest part. And when we expand this one, it is df dx times gh plus dg dx times fh plus dh dx times fg. Well, how do we prove this thing? Well, we can surely give an example of it. When we can try to differentiate this function using the quotient rule and the expanded product rule that we have already written. Well, first we use the quotient rule. Using the quotient rule, we get a long line here, and under the line is cosine x squared, and the rest part is 2x times sine x squared plus 2x times x squared times cosine x squared. This is part of the chain rule, and the whole thing times cosine x, which is the function under here, and then we minus the derivative of the denominator, which is negative sine x, times the numerator, which is x squared times sine x squared. So we should write it in a much clearer form, which is cosine square x over 2x times sine x squared plus cosine x plus 2x to the cube cosine x squared times cosine x plus x squared sine x squared, and which is also equal to cosine x over 2x sine x squared. Well, this is a time here, and plus 2 to the x cube over cosine x squared over cosine x plus cosine square x cosine x squared over x squared sine x times sine x squared. Now we try using the product rule again. This time we take fx as x squared, take sine x squared as gx, and we write hx as 1 over cosine x. And using this, we have f prime gh plus g prime fh plus h prime fg, which is 2x times sine x squared times 1 over cosine x plus 2x cosine x squared times x squared times cosine x 1 over cosine x, and also we have the negative sine x over cosine x squared times x squared times sine x squared. And then we clear it up. We have 2x sine x squared cosine x plus 2x to the cube cosine x squared over cosine x plus sine x squared times sine x times x squared over cosine x to the square. And now we compare these two results from two different method of calculation. We have 2x times sine x squared over cosine x over here, and we have 2x to the cube times cosine x squared over cosine x, and we have x squared times sine x to the square over cosine x to the square. And this is the proof of the product rule of three differentiable functions.